look at it and go, what are on my sides, right? Is it a velocity time graph, acceleration time, or displacement time graph? You have to assess that right away. Go, which one do I have? Yes, sir.
Your report is for what we're missing.
Yes.
We're on his YouTube channel.
I have a whole laboratory. The problem is I have to figure out how to get on this on Canvas. On Canvas very well. Me and Canvas are having a fight. My security software does not like it, and I have to keep my security software on my computer. So between those two things, we are arguing over whether or not Canvas is okay. It seems to work beautifully, by the way, but the district already told me 3 times I got to stop trying to use Teams.
So on our Canvas or YouTube?
So, well, it's all on YouTube, but there's 700 something videos, and they're all labeled like 17-3 Monday 16 Calc 4. And good luck finding the right one.
So your YouTube account, we're gonna look up that.
What?
Like Mr. Resume.
Yeah, you can look up my Mr. If you can find it that way. All right. Anyway, so acceleration for his time. So what's going to happen is Canvas. I'll set it up. I'll put the links in there so you can just click on it. You just go to the right spot. The problem, of course, is I have to get Canvas to stop fighting with me. And that's going to be a thing. Or I have to do it here, which I guess I could do. All right, use this computers for Canvas. All right, so here is my lovely acceleration time graph. So this is, what is this a graph of? This is a graph of what, Rosie? Because you're looking the other way.
Time.
Acceleration on the left-hand side, meters per second squared north. So that's how fast your speed is changing, right? So this is how fast your car is going. This is not how far your car is going. This is how fast your speed is changing. So that's going to make us think really hard here, okay? But to simplify that, we're going to go ahead and attack the first question. We're going to try to attack that first question. See where we're at. Okay.
What does assuming the cart?
Assuming the cart, whose motion is graphed above, starts at rest, what is its speed 3 seconds later? What is its speed 3 seconds later?
So starting at 0 and 4.
It's starting at 0 meters per second, but at 4 meters per second squared. Can a cart have 0 meters per second and an acceleration of 4 at the same time? Yes, we just discussed that. You're at a stop sign. So this cart's at a stop sign, stoplight, when it starts accelerating 4 meters per second squared. Okay? So time equals 0 at 0 velocity, but it does have an acceleration of 4.
Okay, so speed is 12 meters.
Hold on. Let's let everybody have a chance at this before we start spewing answers. Yes, sir.
So the linear sections of this graph would make, if you graph the speed of this cart, it would be a quadratic.
The linear sections the linears that are flat are going to be constant velocity change, right?
Those will be
so they would be straight lines.
When the acceleration is going
yes,
up,
you can have velocity time graph that has a curve on it, correct? Right. In fact, if you were to graph your actual car, that's what it actually looks like. Yeah. Okay, so assuming that the cart whose motion is graphed above starts at rest with a speed of, what is its speed? 3 seconds later. By the way, is at rest? Another technical physics term. It means what? Stop. It's stop. That's what rest means. Okay, yes, sir. So tell me what the velocity would be at 3 seconds. Well, it's going 4 meters per second faster every second.
So 12.
So it'd be 12. How would I find the velocity given an acceleration time graph? Oh, that's not the word.
The slope.
Not the slope.
Area.
That's constant acceleration, right?
Area.
That's the area underneath. Oh, this is not good. Erase it all.
So we need
My
12
square down. Okay.
Where do you find the area under the
So what I'm going to argue is we're going to do this. Oops, it didn't work. Area of the curve again. Right? I'm starting 4 meters per second for 3 seconds. This area represents 4 times 3, which is 12 meters per second. It says speed, so I don't give you a direction, but the direction would be north.
squared.
And it comes down to speed. Right, meters per second.
This is just speed.
Just speed. Acceleration is in meters per second squared.
And you also need the direction.
And then they don't need direction. Why? Because it's speed.
Well, yeah, no, but there was acceleration.
What's acceleration after you give you direction?
That's what this is.
I should give you direction. Do enough worksheets, you'd be like, that doesn't happen every time. Okay, so far so good. Okay, so next question is prove that this is the same area as the curve. Oh, I went too far. Prove it's the area of the curve. What would you do?
You have to just do it.
You would do 3 meters per second squared. Oh, sorry, that's not right. You would do 4 meters per second squared times 3 seconds, yeah?
That's just the equation right now.
Well, that's how you prove it's the same thing, right? The area of the curve would be 4 times 3, right? So you okay with that? Okay. Seconds, by the way, one of the seconds cancels out, and that gives you ironically 12 meters per second, or not ironically at all, because that's what has to be. All right, what's acceleration at 3 seconds? Mr. Gitchall. What's the acceleration at 3 seconds?
Still 4 meters per second.
Still 4 meters per second
Squared.
north.
You're always going to tell us the direction.
I have to.
Yeah.
Otherwise, I'm violating the rule of you have to know the direction of acceleration. All right, how fast is the cart going at 10 seconds? How am I going to figure that out? Area the curve.
Oh, wait, did you go all the way to 0?
So I've got a rectangle with a triangle on top over here. Yeah?
Wait. Huh?
Area of the curve. That whole entire area is going to count, right?
You have to like find the area of every shape.
Well, there's 2 rectangles. There's 1 rectangle and a triangle, right? You see all those shapes. It's 2, right? So we have 4 times 10. You with me? 4 times 10 plus another 1/2. That's 5 times, where does that start? 4?
So it's just 10.
Sorry, what?
10 every
Yeah, okay, you mean the bottom price is 10. You mean the area of triangle is 10. Okay. So that's 10, that's 50, right?
Yep.
Meters per second.
Oh, okay. That it?
So our cart is going almost 100 miles an hour now.
It's a fast car.
That's
How do you know it's going to 50 miles an hour?
Because miles per hour is basically twice meters per second. This is a fast moving car.
Are we expected to know that?
No, but it's something I want you to keep in the back of your mind in case you get a repeat answer.
Wait, what did you say?
Like if I ask you how fast it goes running, and you come up with 100 meters per second, at some point you should pause and go,
That's really fast. That's not.
Oh yeah, we made a mess. Yes, sir. Yes, sir.
For the question, what is greatest acceleration?
What is the greatest acceleration this whole entire time?
What's 9 meters per second squared north?
Perfect.
But if it like below the graph, if it went to like 10, would that be the greatest acceleration?
That is a great question. Yes, it'd be 10 meters per second squared.
Oh, so even if
South,
negative
or
acceleration.
negative 10 meters per second
All
squared
right.
north.
Oh, that's super.
Watch out for that.
Depend on the starting point.
What?
That would depend on the starting point and the distance from. Wait, never mind.
No, acceleration doesn't
Yeah,
count
yeah,
very
yeah.
much. What is its fastest speed? Now you get an early question. What is its fastest speed? What are they actually asking? What do I want? Mr. Vargas.
Sorry.
The fastest.
I'm going to figure out from the graph where the fastest speed is.
Probably the from what we did.
What we did in D? Okay. So, but I need to find the biggest area of the curve is what you're telling me, although you said it really weirdly. Right? So where would my biggest area of the curve be?
Between 6 and 10 seconds.
Nope. Where would it happen? If I'm picking up area of the curve. So we said at 1 second it would be going 4. 2 seconds it would be going 8. 3 seconds it would be going 12. Still going faster and faster, isn't it? Where would it suddenly go from going faster to not going faster?
At 12 seconds.
At 12 seconds. You have to get the area all the way to the 12 seconds. Yeah? I saw some hands up. The question's resolved. Now this is negative. That's going to be slowing down, right? For a while there, he coasts, and then he starts slowing himself down. This tag has to stay out. This is so weird. Making me angry. That has to stay like that.
Well, it's gonna get confusing because the arrows have to go backwards forever. It's just the length of that hallway. It's like all
So I have to add another 1/2, 2 times 9, so that'd be 9. So 59 meters per second is how fast it's going? 9 meters per
I got,
second?
yeah.
What?
I got 57.5.
57.5.
Well, I did, I added the new.
So we had 50. Just need his last triangle, don't
Yeah.
we? The height is 1/2, 9 times 2,
Oh.
isn't it?
Dude, I went to 11. That's my problem.
Oh, you stopped it at 11. So
Yeah.
12. Okay. Is that okay?
Wait, yeah.
The graph doesn't really land on 12, but it kind of does. I was going to
I
say
have a
12.
question. So
Yes.
I did it like this. So I did that triangle and this triangle, and that's 12.5. That's 2. That's 44. So
Okay, so what triangle do you over here?
this little sliver right here. That's wrong with that. So this sliver, this big one, and then this one.
Okay, that's 1/2. So 1/2, 12 times 10. That doesn't make sense. 1/2, the height of this would be
Would be 4.
5.
Instead, I said 2 triangles.
Oh, yeah, the height of
this
this
would be
4 to 9.
5, and the length would be 2 triangles.
So 1/2, 5 times
5 is 25, over 2 is 12.5.
5, okay. And then you went all the way to 11 with the rectangle.
And then 11 times 4
That's
is
44.
44.
Then 1/2, 1
Well, you have to
times
do
4.
plus 2.
Okay, so my guess is that right.
Yeah.
Yeah, it can't be. It's 9, that's 9, and that's,
And that's just 9.
this point here is like 4.5.
Okay, so
Which means if you're triangle, you've got weird sort of geometries here. Where
so then what should I do to fix that?
well, we already did this and this, so just to do a triangle, you just do the triangle on the back end.
I just do the triangle.
Try not to intercept points in the middle, that's when we get in trouble. The logic was good, it just, that point is floating at 4.5, not 4, and that is
Okay.
not an underestimation, not a big underestimation. Okay, when is it going constant velocity? Who's got that for me? Yes, sir.
4 and 6 seconds.
Between 4 and 6 seconds. No, it's accelerating during that time, isn't it? So that's not constant velocity. Alosi,
Wait, I thought it was constant velocity. It's flat.
that is on a what kind of graph?
What is that?
Velocity time graph.
But
This is constant acceleration, which means your speed is changing, right? So you're in a place where you don't have acceleration.
Between 6 and 11.
6 and 11 disagreeing. 6 and 11. You have acceleration the whole entire time, right? Yes, sir.
12 and 14.
12 and 14. What's your acceleration between 12 and 14? 0. That's when you're not accelerating. That's when you're not changing speed or velocity. What? When your acceleration is 0, then you have constant velocity during that stretch, right?
Between
12 and 4, right? 12 and 14. Because at that point, you have no acceleration. No acceleration means constant velocity.
Oh, I'm just raising the
Yes. What? Okay. I think this is the culminating moment. So you have to go, you have to go. In over 10 minutes, you know.
I also need to walk from
Third grader. 4 minutes? Count 4 minutes? All right, pause.